Hello, my dear aspirants. A very warm welcome to you all. I hope all of you are doing great, and I welcome you back to our official channel of Adda 24/7 Northeast. I'm your mentor, Shubhankar Nongsiad, and today I have brought the part 2 number session of our very important topic, that is your time, speed, and distance. So, if you haven't seen the previous video, I would strongly suggest that you go and watch the previous video, because there we have learned the very basic terminologies that is required to cover this particular chapter. So the chapter name is time, speed, and distance. And if you check PYQ, okay, if you go through the PYQ analysis, you would see that there are always 3 to 4 questions coming up from this particular chapter. So that is why this is somewhat important. So let's grab 8 to 10 marks for ourselves from this particular topic. So yesterday, if I give a quick revision, we have covered the relation between speed, time, and distance, and I've explained what it is, how this relation is coming. After that, we have seen the basic relation of conversion of one unit to the other based on the requirement, and we have covered some of the good questions like this one, and along with that we have covered another concept of train passing a person and train passing a tunnel or bridge. This concept also we have covered yesterday. So today I want to move to relative speed concept, which has been seen that this particular topic keeps on repeating again and again. So this is, you can say, more important for us, more important and more heavy weightage in this particular part. So if you check, let me show you once, see how many questions they have asked in previous LDA. See, this many questions, okay? Then this many questions. See, all of these questions are based on a relative speed concept. So let's understand one by one how to solve these questions by using the very basic that we have, and the best approach to solve this question in a matter of a minute or two. So let's understand. Firstly, in order to understand relative speed, let's understand this particular concept of a body in motion. So I've explained what is a motion. Yes, what is motion? Whenever your body starts moving, we say that the body is in motion. Whenever the body starts moving, we say that the body is in motion. Now, yesterday what happened is, when I looked at the ball, okay, I was considering ball's initial position and I was considering ball's final position. Yes, and based on that I got this particular path as your distance. But if you notice, the reference point for us was this particular point, which was what? Which was fixed. So in fixed, okay, if my reference point is fixed, in that case, the speed that I'll be getting is known as your absolute speed. Absolute speed. That means the exact speed with which the body is moving, because I am taking a fixed point as my reference. But as we come to relative speed, see, the name such is relative, right? That means the speed that you'll be getting would be related to something or the other. For example, see this one. Suppose this is a train, okay, this is a train which is moving in this direction, okay, and along with that, suppose this is a person whom we are looking from the top, and even he is moving in this direction. So now if I want to compare the speed of these two bodies with respect to each other, then in such cases we would have a relative speed. Okay, in such cases we won't be able to get the absolute speed, because here no one is fixed. Both bodies are in motion. So whenever both bodies are in motion and we try to compare the speed between both of them, we use this particular concept of relative speed. Okay, and relative speed can be segregated into mainly two parts. What are those two parts? Very simple. First part would be when both the bodies are moving in the same direction. See, both of them are moving towards this point. Yes, same direction. And another case would be when the body are moving in opposite direction. So when the body are moving in same direction, suppose I say that this particular train, okay, which is a little faster, has a speed of ts, speed is ts, and this particular man, or whatever you can take, car or something, the speed of this particular person is tp. Okay, in that case, if I want to see what is the relative speed between them, so relative speed would be simply ts minus of tp. And why are we writing ts first? Because ts is the body which is moving faster as compared to the slower body. That's why ts is in front and tp is in behind. That's it, nothing else. Okay, and why is it negative? So you can understand like this. See, if this particular person, okay, this is the person which you are talking about, if he wants to catch this particular train, okay, so he'll has to increase his speed, right? But to catch, it'll take some time, because even this moving in the same direction, so it will catch him, but it'll take a while to catch. That is why we are getting negative sign. That means it is slower, right? It is slower. That is why we are getting negative. So how to remember? It's very simple. You think like that. Suppose I am running in this side and you are trying to catch me. So you would catch me in a while, but it'll take some time for you to catch, right? So this particular time that it's taking to catch you is what is your relative speed, and this speed will always be the difference between them. For example, if I'm running with a speed of 10 kilometers per hour and you're running with a speed of 5 kilometers per hour, so how much speed do you have to increase to catch me? You would say I have to increase my speed further by 5 kilometers, so that 5 plus 5 becomes this particular speed which I'm running with. Got it? So when your body are moving in same direction, your relative speed will be the difference between the both bodies. In the same case, if the body is in opposite direction, then your relative speed would be addition of both the speeds. So that will come later. Let's understand how are the question frame based on relative speed, and how do we utilize the same formula that I've taught you before. Speed is distance by time. Here also no new formula will be learning. We are going to utilize the same formula, same concept, just the question language would differ. Let's check the question. See here. This is the first question given to us. What's given? Let's understand. A train 120-meter long running at a speed of 72 kilometers per hour. Okay. So the first condition says that we have a train whose speed is how much? Train speed I'm writing as TS is 120. Oh, sorry. It is 72 kilometers per hour. Kilometers per hour. And the length of the train, so I'm writing TL, is 120 meter. Right? Running along at a speed this one. Okay. How long will it take to pass a man who is running at 18 kilometers per hour in the same direction? So we are comparing this particular train to a speed of a man. Yes. Suppose I consider that man as M. Okay. And his speed is given to us how much? 18 kilometers per hour. Okay. And they want us to get the time. The time. Okay. The time. Okay. To pass this particular man, because even he's running in the same direction, right? So what we'll do? Same concept. We are going to utilize speed is equal to distance by time. But my friend, as here, both of the bodies are moving. And one more thing, both of the bodies are moving in the same direction. Same direction. We'll be getting here a relative speed, not the actual speed. So relative speed is what? When two bodies are moving in same direction, the relative speed is what? Is the difference between them. Is the difference between them. So just take the difference of them. So we'll write 72 minus of 18. Okay, this is the relative speed. And if you see, both of the unit are in kilometers per hour, and I'm looking at here, and I'm looking that the time train length is given in meters. So I have to convert this into meter per second. So to convert this into meter per second, we have learned yesterday that we multiply 5 by 18, and in that way this entire part has converted into meter per second, my friend. And this is equal to the distance, right? So when our train passes a man, we have learned yesterday, when a train passes a man or a pole or a fixed object, in that case, what will be the distance? The distance would be the length of the train itself, right? So instead of distance, I'll write train length and I'll divide it by the time which I want to find. That's it. Just simplify this equation, my friend, and you'll get the answer. So 72 minus 18, if you do it, you'll be getting 54 into 5 by 18 equal to 120 divided by the time which you want to find. So if I cancel 18 and 54, 18 into 3 is 54. So 3 5s are, we are getting 15 out here. Okay, what are you getting? We are getting 50 this side. And this side is 120 divided by the time. So if you cross multiply, this time goes there and 15 comes below. So simply your time will be what? Time will be 120 divided by 15. And if I cancel this, how much you're getting? So 5 3s are 15. 5 24s are 8. That means, my friend, this train will require 8 seconds to cross this particular man. To cross this particular man completely. Okay, this is how you utilize relative speed concept. It's very simple. It's not that difficult. Always remember, when both the objects are moving, and I'm comparing both the objects which are moving together, that is the case when you'll see relative speed concept coming up. Let's see one more example to clarify our concept better. Now see, this is the question another one. Okay, exact similar question, but just that they have changed the variables, they've changed the number, and they have pasted in the next year paper. Let's do it. Firstly, what's given? Our train is 150 meter long. So they have given us the train length, which is your 150 meter. Okay, and is running at 60 kilometers per hour, and they have also given us the train speed, which is 60 kilometers per hour. Okay, if a man is going at 6 kilometers per hour in the same direction, again exactly same question, we have man moving in the same direction with a speed of 6 kilometers per hour. Both of them are moving in the same direction. In that case, how long will it take the train to pass? That means we have to get the time. Can you do it? Can you do it, my friend? Yes, let's do it quickly. So we know that speed is equal to distance by time. But as both of our body are moving That means we have to get the relative speed. Simple. So relative speed will be what? Both of them are moving in the same direction, so you have to take the difference. So 60 minus of 6 would be how much? You would say, so it will be 54. And 54 is what? 54 is kilometers per hour. So we have to convert into meter per second. So what we'll do? We'll multiply by 5 by 18. Okay, equal to distance. How much is? Distance would be the train length because we are crossing a man. So 150, and this will be divided by the time that we want to find. So 18 and 54 will get cancelled out, and you'll be getting how much? You'll be getting 3 out here. 3 5 is 15 equal to 150 divided by t. So the time that you'll be getting now would be 150 divided by 15, which is how much? 10 seconds. Easy, my friend. Yes, I hope you've got it. Okay, this is how you do it. Let's see another question quickly. Let's see another question, my friend. Okay, out here, see, now they have changed the question a bit. A train 125 meter long passes a man. Okay, always write down whatever is given. First they have given a train's length. Train is how much? What's the length? 125 meter. Okay, passes a man, so it's crossing a man. That means the distance traveled would be the train length itself. Running at 5 km per hour in the same direction. Okay, the man is running with a speed of 5 km per hour in the same direction. Okay, so that means my train speed would be something. Okay, but that is also in the same direction. Okay, which is going, train is going. Okay, wherever the train is going, the man is also running that side in 10 seconds. Now they have given you the time. So what do you want? We want the speed of the train. Very easy. Yes, same concept. We have speed is equal to distance by time. But out here, as both of the objects are moving, we'll get a relative speed. Now what will be relative speed? So the relative speed would be the speed of the train with which it's moving minus the man speed, which is given to us 5. Yes, and this will be equivalent to the distance will be how much? As this train is crossing a man, the distance will be the train length itself, which is 125 meter, and we'll divide this by the time given to us, that is of 10 seconds. Just simplify this and you'll be getting the answer. But the thing is, if you notice out here, again the speed is given in kilometers per hour, so you have to convert it into meter per second. Okay, so what we'll do is, you have two options. First thing is, if I see the option, I can see that it's written in kilometers per hour. So what we can do is, out here when I put 125, this is in meter and this is in second. Let's convert meter per second to kilometers per hour. It will be easier for us. Okay, in that case, we'll directly get the answer in kilometers per hour. So to go from meter per second to kilometers per hour, what we have to do? Remember, I asked you to do it the reverse. Okay, so we are going from meter per second to kilometers per hour, so you have to multiply by 18 by 5. Yes, so just multiply 18 and divide it by 5. That's it. This will be your answer. 5 25s is 125. 5 2s is 10. 5 5s are 25. 2 9s is 18. So that means train speed that we'll be seeing is train speed minus of 5 equal to 5 9s are 45. Okay, which will tell us that the train speed will be 45. This 5 goes there, it becomes positive 5. So 45 plus 5 would be 50. What's the unit? Kilometers per hour. How? Because we have converted this part also in kilometers per hour. So automatically whatever you'll be getting, it will be always in kilometers per hour, which is my option number B. I hope you got the idea. Yes, the psyche you have got it. Okay, let's check another one. See, a jogger runs at 9 km per hour alongside a railway track of 120 meter ahead of the engine, and 120 meter long train running at 45 kilometers per hour in the same direction. Okay, let's understand this particular condition, because out here if you see, okay, if you see what's happening is, there is a jogger. Okay, there is a jogger, right? There is a jogger. Let me draw the condition for you. So this is the train. This is the train. Okay, along with that, in front of the train there is a platform as well. Platform, you know, from where the people are getting up, from where the people would get up. Yes, this is the platform, and alongside there's a person who is running. Okay, this guy is running in this direction, right? So necessary condition that they have given is the jogger is running at a speed of 9 kilometers per hour, and the train is moving with a speed of how much? Train is moving with a speed of 45 kilometers per hour, and along that they have given that the length of the railway track. Okay, railway track is how much? That means the platform they have given. This is what? This 240 meter. Let me use another color. 240 meter, my friend. And the length of the train is also given to us, which is your how much? 120 meter. So this concept we have learned yesterday, right? Whenever a train crosses a tunnel or a bridge or a platform or a track, In that case, the distance would be how much? Distance would be the total. Yes, you have to take the train length. Along with that, you have to take the railway track length as well. So you have to do 120 plus of 240. We have learned this yesterday, which gets us 360 kilometers. This is the distance. Okay, sorry, meter, not kilometer. This will be meter. Okay, and now we can utilize the formula that we have. What is it? So speed is equal to distance by time. But as here I can see that a man is running and a train is moving, so we'll get the relative speed. What will be the relative speed, my friend? Both of them are moving in the same direction, so we take the difference of the speed. So 45 minus of 9 would be how much? 45 minus of 9 would be 36, my friend. 36, but this in kilometers per hour. So let's convert this into meter per second. And how to convert into meter per second? Just multiply 5 by 18 to it. Now this entire term has become meter per second. And this should be equivalent to what? Distance. How much distance we are covering? 360 meter, my friend. Divided by the time taken to cross. So this is what we have to find. Easy. Just cancel the unnecessary terms. For example, I can cancel 18 and 36. Right? 18 into 2 is 36. So let's cancel. 18 2s is 36. So 2 5s is 10. Which is equal to 360 divided by t. So therefore, the time taken will be how much? Just cross multiply them. So you have 360 out here. This 10 goes below 0, 0 cancel. That means you'll take 36 seconds, my friend, to cover this entire journey. Which is how much? Option number C. Option number C. I hope you've got the idea. Yes, yes. Okay, perfect. So the next topic would be opposite direction. So as I mentioned before, if you see here, you will notice that this particular object is moving this side and this other particular object is moving which side? This side. So always remember, when both the objects are moving in opposite direction, see opposite, right? He's moving this side and he's moving this side. In that case, your relative speed of both the object would be what? The sum. The sum. The relative speed would be speed of this body A plus speed of the body B. And why is it plus? Because you see that both of them are moving in the same direction, so they would meet earlier. Okay, they will meet earlier, right? That is why we are adding the speed. Okay, there is an increase in speed. And also the best example would be if you go in a train. Okay, when other train crosses, do you notice that the speed is like it increases a lot? You can't even see the people out there, right? It moves so fast because of the relative speed concept out there. Okay, so when it's same direction, then remember like this: same direction means subtract, opposite direction means add. That's it. This is the concept that is utilized. Other concepts are exactly same. We are going to utilize the same basic formula that we have learned, that speed is equal to distance by time, my friend. Okay, let's check. Let's check the question. See here. A 120-meter long train running at a speed of 120 kilometers per hour crosses another train running in opposite direction with a speed of 80 kilometers per hour in 9 seconds. What is the length of the other train? Let's do it. Let's do it. Easy concept. What's given? We have the train length. Okay, this train length number 1, which is 270 meter. Okay, train length number 2 we do not know. Along with that, they have given the speed of train 1. Speed of train 1 is how much? It is 120 kilometers per hour, my friend. And speed of train 2 is how much? It is 80 kilometers per hour. And both of them crosses each other at what time? They crosses each other at a time of 9 seconds. Yes, can we do it? Absolutely, sir. Let's do it. So we have that speed is equal to distance by time. But again, as here both the trains are moving in the opposite direction, we'll have to utilize the relative speed concept, right? What would be the relative speed? Sir, as they are moving in the opposite direction, we have to add these speeds, right? So 120 plus 80 would be 200 kilometers per hour. But again, this particular term is coming in kilometers per hour. I want to convert into meter per second. So what we do it? We just multiply by 5 by 18. Simple. Now this term has become meter per second. Equal to distance will be what? Now two trains, when they cross each other, if you notice, okay, you would look like we have to take the length of this particular train length 2, and we have to take the length of this train as well, because both of them will be crossing each other's length, right? So the total length would be both train lengths added to each other. So train length number 1 is 270, so just write 270 plus train length number 2 is what we are interested to find, and divided by, in order to do this, they took entirely only 9 seconds to cross each other. Now we can cancel the unnecessary terms. Okay, you should see this 9, if it goes there, this 9 would go at the top, right? So you're getting 200 into 50, into 5 by 18 into this 9 goes there, so 9 comes here, equal to 270 plus of TL2. So if I cancel 9 2s are 18, 200s are 200, you would see that I'm getting out here how much? 5 into 100 is 500, and this is equivalent to 270 plus train length 2. If you take 270 there, this 270 gets subtracted because out here we have positive. So 500 minus 270 would be 230 meters, my friend, which you can see is an option number A. I hope you're understanding it well. Easy concept, right? Let's see another question. If it's similar, then I'll leave it for you. A train one moving at the speed of this much, cross the train this much, okay, opposite, okay. The speed of the second train. Okay, we want to get the speed of the second train, so let me show you. This is a bit different. But the concept that we are using is the same concept, okay? No other concept you have to utilize. Utilize the same concept every time. Firstly, they have given that the train length number 1 is how much? It is 108 meter. Okay? And then it is moving at a speed of how much? 50 kilometers per hour. Along with that, we have train length number 2. The other train is 112 meters long, coming from opposite direction. Okay, be careful, opposite direction, and it takes entirely only 6 seconds to cross that particular train. So we want the speed of the second train. It's easy, right? What do? We write that, sir, out here. The relative speed will be equal to the distance divided by the time. What would be relative speed, sir? Relative speed would be speed of train 1 minus speed of train 2. So train 1 speed is 50. Okay. Minus train 2 speed we have to find. Okay. And this particular term is in kilometers per hour. So we can make it meter per second, or what we can do is we make the other term as kilometers per hour. Okay. Equal to distance is how much? Distance is what? The total length of both the trains together. 108 plus 112 will be getting 120 meter. Yes. Sorry, 220 meter. Very sorry. Just a minute, let me correct it. 220 meter, and this will be divided by 6 because it's taking 6 seconds. But now this is what? This meter per second. So I want to convert it to kilometers per hour. So we multiply how much? 18 by 5. In that way, this converts into kilometers per hour. Our requirement. Okay, now just cancel the unnecessary term. Like we can cancel 6 and 18 by 3 times. Cancel 5 and 22 by how much? 54 times. Sorry, not 54. 44 times. Yes, we got it. So this is how much? This is 50 minus of S2. And this will be equal to how much? 44 into 3. Yes. Okay. This is how much? It's going to be 132. 132? Yes. So speed of train 2 would be how much? Speed of train 2 would be, if you see, okay. I think there's some mistake out here. Let me check once. Train length number 1 is 108 meter. Okay, this much is the speed. Okay. Oh, relative speed should be addition, right? We have to add out here. I have subtracted. Sorry. 6 seconds. Okay. So 112 is 220. Okay, 220 divided by 6. Okay. Into we want to convert it to kilometers per hour. So 18 by 5. Okay. 5 4s are 20. Yeah, 44. Okay. Yeah, this is the thing, right? So S2 would be 132 minus of 50, which will give me how much? 82 kilometers per hour. Okay, it was correct. Okay, I just made a mistake that relative speed should be add out here because why? Both of them are moving in opposite direction, right? So we have to add them. So 82 kilometers is the absolute correct answer, my friend. Okay, so I hope you can do this particular question. Please try this. Okay, and answer down your comments below. Okay, answer down and comment below your answer for question number 153. Okay, and if you like the session, make sure to type down good session. Okay, good session. In that case, I'll get more motivation to make such videos for you. Even though I'm lacking smartboard currently because I'm posted somewhere, I'm working from somewhere else, but still the effort should not leave the consistency away. That's why I'm making as many videos as possible in this particular situation as well. Right? So I hope you like the session. Along with that, we have one more concept left. That is your average speed concept. and obviously we won't be able to cover this particular concept in this video, so maybe I'll take another video for you where we'll learn this concept in like 5 to 6 minutes, right? So I hope you enjoyed the session. If you enjoyed the session, make sure to like the session, and also if you want, you can also join our paid batches, which is available for you, okay, at a reasonable price. To know the details, just contact this particular number and get the details. Get yourself counseled to know all the details, because see, after MPSC LDA we have DSC LDA coming up for us, DSC LDA. Then obviously many of you have, I think, filled the form for sub inspector also, Meghalaya sub inspector. That exam also is awaited, right? And after a while we'll again be able to see MPSC LDA notification out coming up, right? So in order to boost your preparation, you have to start preparation from now itself. So join our batch. Along with that, if you want, if you don't want to join the batch, then at least try to get yourself the test, mock test for practice, because you need to feel the pressure from now itself, so in the exam the pressure feels normal to you, right? So given number below is the number where you can contact and ask for any details that you want. So thank you so much. I'll meet you in the next session. If you like this session, make sure to like the session. Along with that, comment down below good session, so that we'll make another video for you. So thank you, take care, and keep streaming. Bye bye.